All of you, tell your departmental friends to join. We are going to start in 4 minutes. Very good afternoon to one and all. Good afternoon.
Good afternoon, ma'am.
Good afternoon, ma'am.
Myself Amrita Afre. I am Assistant Professor, Artificial Intelligence and Data Science Department. I welcome all of you on behalf of Artificial Intelligence and Data Science Department and Artificial Intelligence and Machine Learning Department. Today, we have gathered here on the online platform for the inauguration ceremony of our departmental club, CoDE. Krishna? Krishna?
Yes, ma'am.
Share that. Okay. So last month, CoDE AIDS and CoDE AIML committee members were selected. So CoDE AIDS committee members, I'm going to read out all the names. President Sarthak Nagoshe, Vice President Yashodan Deshmukh, Secretary Kaivalya Surve, Admin Arya Bhusane, Tech Lead Ojaswin Kamkar, Web Development Yash Khande Bharat, Graphic Designer Janhavi Dhaikude, Sai Ahir, Content Lead Shreya Sonkusre, Gurvanch Kaur, Publicity Lead Sakshi Sonavne, Outreach Lead Mayura Rangadhan. Now, CoDE AIML committee members, President Nachiket Borwadkar, Vice President Sejal Kahane, Secretary Aditya Ingole, Admin Kiran Shetty, Tech Lead Shreya Mainkar, Web Development Mayuri Thorar, Graphic Designer Madhura Mirazkar, Rushikesh Panchal, Content Lead Riya Jagtap, Juhi Gurram, Publicity Lead Krishna Fafre, Outreach Lead Ayush Kadam. Congratulations to all CoDE AIDS and CoDE AIML committee members. Now, I invite Mayura Rangadal from CoDE AIDS committee to welcome our audience on behalf of CoDE AIDS.
Thank you, ma'am. So I'll start my speech with this beautiful thought that sometimes what you need is to start something new because a change is what is needed for growth. At first, it always seems impossible until it's done. Similarly, the joy of life. It comes from our encounters with new experiences. And hence, there is no greater joy than to have endlessly changing horizon. For each new day to have new and different sun. Don't settle down and sit in one place. Move around. Be nomadic. Make each new day a new horizon. Success is not final. Failure is not fatal. It is the courage to continue that counts. Again, I repeat, it is the courage to continue that counts. Now, to begin, I am Mayura Rangda, second year student of Department Artificial Intelligence and Data Science. On behalf of the department, I desire to extend a gracious and inclusive welcome to all of you. It's gratifying to look around and see that the huge number of people have joined our CoDE inauguration ceremony. The Department of Artificial Intelligence and Data Science has been started in the academic year 2020 and 2021, which is an undergraduate program and is approved by AICTE, New Delhi, and is affiliated to Savitribai Phule, Pune University. As a focused branch of global technology, artificial intelligence and data science have enormous scope of development, with plenty of opportunities under this field. The key area of artificial intelligence and data science is to deliver the intelligence through multifaceted programs in order to solve a specified problem by making the most possible predictions based on the information provided. Whereas now data science be the current training technology that has conquered the industries around the world. It has brought about a fourth of industrial revolution in today's world. This is a result of contribution by massive data and the growing need of industries to rely on the data and to create better products. We have become a part of data-driven society. Data has become a dire need for industries, and data need to be handled very carefully. Our undergraduate program provides a base for students to establish their interests and pursue them, through which we as a student can contribute our best to the society, to put forth our ideas, creativity, innovation in the best possible way. Now, today is the new beginning to welcome all future's marvelous opportunities, that the best is yet to come. And I am deeply honored on behalf of Department Artificial Intelligence and Data Science that I've got the opportunity to welcome you all. Thank you, everyone.
Now I invite Ayush Kadam from CoDE AIML Committee to welcome our audience on behalf of CoDE AIML.
Thank you, ma'am. So, new beginning is an adventure waiting to be had. Whatever you do or dream, you can begin it and achieve one step at a time, one day at a time. Embrace the uncertainty of trying something new. Hello, everyone, and a very good afternoon. So, on this auspicious occasion, on behalf of AIML department, I would like to welcome you all in the inauguration of our college newest established club of data engineers. I am Ayush Kadam, second year student from Artificial Intelligence and Machine Learning. AIDS and AIML departments opened a new door of shining future for students in the form of code. So, today is the bright day of a long, beautiful journey ahead. PES Modern College of Engineering started departments of Artificial Intelligence and Machine Learning in the academic year 2021, which is affiliated to Savitribai Phule Pune University, SPPU. Artificial Intelligence and Machine Learning is an associated branch of computer science, which emphasizes on technology for generating intelligent machines. ML is a subset of AI, which allows the machine to automatically learn from past data without programming explicitly. Machine learning powers the most impressive capabilities in an AI platform. Our undergraduate program furnish with pre-knowledge for the students to make them believe in academics, by which they will contribute their excellence socially. The goal of AI and ML is to make a smarter computer system like humans to solve complex problems. So, on welcoming note, I would like to say, star shines at night, some stars shines at a bright day. It's our pleasure to welcome such a star, Mr. Soubhik Das, the honorable chief guest of our today's inauguration event. We welcome you, sir. It's our pleasure to have you. And those who put their soul and heart in uplifting others attain dignity, yes, I wholeheartedly welcome all the dignitaries, our faculties and committee members. Last but not least, I welcome my all other college mates who give their valuable presence to our inauguration ceremony. We welcome you all. Thank you.
Thank you. Now I request our head of the department, Professor Dr. Sadha Pandit Madam, to guide our student.
Hello, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, okay, thank you. Okay, good afternoon to one and all. It's my honor and privilege to welcome our today's guest speaker, Mr. Soubhik Das, co-founder and CEO, Manastik Technologies Private Limited, faculty members, and my dear students. We are attending our online regular classes, but that is not enough. You have to carry the regular activities like your co-curricular and extra co-curricular activities at least in a minimum form. In the view of the same, Department of Artificial Intelligence and Data Science and Department of Artificial Intelligence and Machine Learning prepares a very well platform, CoDE, the Club of Data Engineers, to the students to showcase their talents. There are many objectives behind this platform. Importantly, the first one is to involve students with extracurricular activities and ahead of academic part, to generate opportunity of learning by doing, to develop leadership skills among the students, to organize different co-activities for and on behalf of the students, and to facilitate conducive academic environment into the department. So my dear students, to fulfill all these objectives, we need your support. Without your support, this would not be possible. I congratulate and thank all the elected members of the CoDE Club. I also thankful to the management, Professor Dr. Kalyani Joshi, Principal, Professor Dr. Nilima Kulkarni and Professor Dr. Suhasini Itkar Ma'am, Vice Principal, for their support and guidance for the formation of CoDE Club. Dear students, I wish you all success. God bless you all. Thank you so much.
Thank you, ma'am, for these encouraging words. Now the time has come to reveal our departmental club code. And this is our code club website.
Hi friends, so this is our official website. All the upcoming events will be available on the website along with the registration link or the meeting link. Also, the winners will be displayed on our website. So you can save this link of our code's official website for future reference.
Today we have with us our guest speaker, Mr. Soubhik Das. I welcome you, sir, on behalf of Department of Artificial Intelligence and Data Science and Department of Artificial Intelligence and Machine Learning, PES Modern College of Engineering, Pune. I am privileged to introduce to you our guest speaker. He is a passionate about artificial intelligence in healthcare and is an innovator with 9 patents published and several papers published. He is a co-founder of Manastik, machine learning specialist, and he is alumni of our PES Modern College of Engineering, Shivajinagar, Pune. We are privileged to have such great personality for our today's club CoDE inauguration. I request you, Mr. Soubhik, to guide our student. Now I hand over mic to you, Mr.
Sure.
Soubhik.
Yes. So firstly, thanks a lot for inviting me, and thanks a lot for the introduction, and congratulations to all the members of Code Club. So I would like to say that when I was in during engineering career just few years back, there was no specific department for artificial intelligence. I used to talk about it to lots of teachers, people, mentors, even outside of college friends, that we need it, and we need it because the growth of AI is such that we need people to work specifically on AI and not just as kind of a part of software engineering. That was how the growth of it, and I see that it has happened now. So there were talks of that even engineering taking place in Android too, for as a kind of separate branch during the computer revolution of the last decade. But it's a good thing to see that artificial intelligence has finally taken form. That was, I think, needed since a very long time. So I hope I'm audible clearly, and I will share my screen.
Yes, sir, you are audible. You can share your screen.
Yeah, so a very warm welcome. It's great to be here, and a very good afternoon to everyone as well. So I'll go through the agenda quickly. So what y'all can expect from me today, I will hit the core of artificial intelligence, but y'all will never feel that there is an information overload or anything. If there is, we can get with some fun sessions in the middle. So, about me, as ma'am introduced, I've been associated with AI for quite some time now, and being passionate about technology, I was privileged to work on several research papers as well as patents in the past, and I always look forward to being in an environment that highly fosters innovation, leadership, and entrepreneurship. And in the past, I was privileged to be an Intel student ambassador and also Intel software innovator. Yeah, I'm graduated from Modern College of Engineering in the branch Computer Engineering Department in 2018. So to begin with, let's look at a short story. So, this is a story of a boy who has got a little idea about artificial intelligence and computer vision, that too after a few months. And although he's not completely aware of it, he learns it and is trying to implement the same along. So, all in all, we might possess ideas, but without the technical know-how, we might not be able to test or implement the same. And if we are not able to implement the same, we won't be getting absolutely any credit or any benefit out of the idea. So for that, we need to really know the concepts well. We need to know how to implement it, not just theoretically, but also on a very practical note. Think about it. So let's think more on the previous story. It's a short story though. We need a preliminary understanding of AI. Artificial intelligence includes the simulation process of human intelligence by machines and special computer systems. The examples of AI include reasoning, learning, and self correction. After years of practice, experienced developers, what they do is they start thinking of software and problem solving in terms of data flows through a system. For example, let's consider a coffee making machine. In that, there is a flow of water, cups, coffee, cups, and extra from all the sources to the destination. The water starts from the faucet. Coffee comes from the bag that you have in the pantry and the grocery before that. The cups from a cupboard and extras come from different sources depending on what they are. There can be a variety of them. These materials flow through a series of steps that manipulate, transform, and mix together. The initial state is the raw resources located wherever they are stored, and the final state is a series of cups filled with coffee plus extras. The destination is somebody drinking or even eating the same coffee in this case. Let's keep thinking what more can we infer from the short story. So brief history, let's walk through the history of AI, how it was developed, and that has a very strong correlation in fact to where we are right now and where we might be going forward. So Turing proposed that a human evaluator would judge natural language conversations between a human and a machine designed to generate human like responses. The evaluator would be aware that one of two partners in conversation is a machine, and all participants would be separated from one another. John McCarthy, we'll see his face in a while, who coined the term in 1956, artificial intelligence, defines it as the science of and engineering of making intelligent machines. Other names for the field have been proposed, such as computational intelligence, synthetic intelligence, or computational rationality, even. 1960 was a milestone since then, since neural networks could be used for the very first time in binary classification, making two classes, predicting which class it is out of the two. And in 1980 was once again an important year because, as if you all have gone through deep learning, you all might be aware, Geoffrey Hinton, who is widely known as the godfather of deep learning, uh, he is also pioneer of artificial neural nets, demonstrated the use of generalized backpropagation algorithm for training multi-layer neural networks that has been widely used for practical applications, and in a way we can say that he's woke up the sleeping monster. In 1997, IBM's AI powered chess engine beat Gary Kasparov, who's a chess grandmaster, who was the best chess grandmaster at that point of time, which was tremendous, and that is more than almost 25 years back. Pioneered by Dr. Sebastian Thrun, a Stanford's Stanley won the DARPA Grand Challenge self-driving car competition in 2005, which paved the way for autonomous driving later on. He's widely known as the godfather of self-driving car, Dr. Sebastian Thrun. And finally, we know Google developed its RankBrain algorithm in 2015, which kind of put search in a different space altogether. So the evolution of artificial intelligence techniques and the increased gathering of data require an ability to perform computations. Without a corresponding increase in the availability of compute power, AI would not be able to take advantage of these. Big data is a term that describes large, hard to manage volumes of data, both structured and unstructured, that inundate businesses on a day to day basis. But it's not just the type or amount of data that's important, but what the organizations do that matters. So big data can be analyzed for insights that improve decisions and give confidence for making strategic business moves. We know we better understand the computer algorithms, be it how to read from a file faster or how to develop a sorting algorithm even on a quicker note, isn't it? That is far better than what it used to be in 1900s. Lastly, more firms are willing to invest, and more people are open to investing heavily in AI now than ever. I recall while I was in my engineering career, a friend of mine He came up with a new sorting algorithm, and that was, and then product of it was an IEEE paper. So he tried to improve the time complexity of one edge case. So people are coming up with these on a very frequent are coming on this very frequently these days. Artificial intelligence is the field of computer science dedicated to solving cognitive problems commonly associated with human intelligence, such as learning, problem solving, and pattern recognition. AI, as we know, as often abbreviated as, may convert robotics or futuristic scenes, the ones which we see in Transformation, something like those, into non-fiction of modern day advanced computer science. Professor Pedro Domingos, a prominent researcher in this field, described five tribes of machine learning comprised of symbolists with origins in logic and philosophy, connectionists stemming from neuroscience, evolutionaries relating to evolutionary biology, Bayesians engaged with statistics and probability, and analogizers with origins in psychology. Recently, the advances in the efficiency of statistical computation have led Bayesians being successful at further gathering the field in a number of areas under the name of machine learning. That's the umbrella under which it operates. Similarly, advances in network computation have led to connectionists gathering a subfield under the name deep learning, which is even at a depth greater than machine learning. And machine learning and deep learning are both computer science fields that are derived from the discipline of artificial intelligence. We will see their correlation soon. Initially, there were lots of debates as to whether or not put machine learning and AI in statistics, but then due to its tremendous and humongous applications in science, it has been classified as computer engineering and computer science rather than in statistics or any other branch or sub branch of science. John McCarthy, here is known as the father of AI widely. He coined the term AI and is well known for maintaining its existence post Sir Alan Turing. The Dartmouth Summer Research Project on Artificial Intelligence was a seminal event for AI as a field. That was what many believe the birth of AI. In 1956, a small group of scientists gathered for the Dartmouth Summer Research Project on AI, which was the birth of this field of research. Artificial intelligence, machine learning, and deep learning are the most common tech buzzwords, yet most commonly confused with each other. Whilst having a close connect, these terms cannot be interchanged and used. We need to keep the relationship between these three fields very clear in our minds. In its simplest term, AI is the superset. It's the absolute superset. Cannot get anything bigger than this. And ML is a subset of AI. It is a part of AI. It's not completely AI. And deep learning is again a subset of machine learning. So one inside the other. The age old industrial revolution has extended human mechanical power. This new age revolution, the second age machine, is going to extend our cognitive abilities, our mental power through artificial intelligence. Now let's look at the types of AI. These are the types of AI depending on how it has disrupted the industry. A vertical AI startup delivers a product based on AI, owning the entire workflow to solve a very targeted customer need. The needs are defined clearly first. These startups develop a complete product from end to end, starting with understanding the business case to monitoring product performance. AI is a powerful tool that can help companies achieve superhuman performance in specific tasks. And AI opens up new possibilities to deliver new tasks, improve existing products, or automate tasks. Vertical AI startups optimize their predictions through a specific use case. If they're successful, they can perform better in this use case than humans or competitors. Horizontal AI company enables data scientists to complete the data science workflow more efficiently. Thus, the customers of horizontal AI startups are generally data scientists or development teams. Horizontal AI companies pick specific or multiple parts of data science workflow and improve them. They don't work on specific needs. They generally focus on the flow and how they can improve a part of it or the entire flow. A horizontal AI product could, for example, focus or service could, for example, focus or helping data scientists monitor their models. Horizontal AI products are use case agnostic and are used to develop any AI based product. We all can figure out what each images indicate, as the applications of AI can be virtually anything in today's world. But I'll go through one in detail. AI in education. Although, yes, the image on the last one is the one representing an education. Although the education sector is the one most influenced by humans, artificial intelligence has slowly begun to seep its roots in the education sector as well. Even in the education sector, uh, this slow transition of AI has helped increase productivity among faculties and help them concentrate more on students than office or administrative work. Some of these applications in the sector include administrative tasks automated to aid educators. For example, the idea that this boy thought about some time back, automated attendance system, that the teacher does not need to, or the faculties that do not need to interrupt with the attendance system at all. If through the use of image recognition and advanced deep learning, automatically through face recognition, their attendance can be marked. And then creating content to be delivered on the classroom on a very regular basis. Then voice assistants, for example, if the teacher speaks in a particular language but there are two to three students in the class who are not able to understand that language, then through automatic language conversation through AI, everybody can understand. And personalized learning, we all learn at a different pace, we all learn differently. So if AI can help us get in to get help us teach in that way which helps us the most, there can be nothing better than that. So undoubtedly machine learning is the most in demand technology in today's market. Its applications range from self-driving cars to predicting deadly diseases such as Alzheimer's and even cancer. In fact, Google published just recently, few years back, Google published its research paper which dealt with detecting a diabetic retinopathy, which is a kind of blindness in the eye through machine learning. And if the disease is detected early, there is a huge possibility that it can be cured almost completely. That is how far AI can take us. And detecting early is not really a thing, even with the best possible doctors today. But machine learning, to a great extent, can help us reach there. The applications in machine learning, which we all know, are really quite fascinating. So, machine learning is a method of data analysis that automates analytical model building. It is a branch of AI based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. Because of new computing technologies, machine learning is not like the machine learning in the past. It was born with pattern recognition and the theory that computers can learn without being explicitly programmed to perform specific tasks. Researchers interested in AI wanted to see if computers can learn from data. The iterative aspect of machine learning is important because as models are exposed to new data, they're able to independently adapt. They learn from previous computations to produce reliable, repeatable, and actionable decisions and results. It's a science that's not new, but the one that has recently gained fresh momentum. While many machine learning algorithms have been around for a long time, the ability to automatically apply complex mathematical calculations to big data over and over, faster and faster, is a recent development. Here are a few widely publicized examples of machine learning applications you may be familiar with. The heavily hyped self-driving Google car, you all might be aware of it. We just went through Dr. Sebastian Thrun's work on that. That's the essence of machine learning. Online recommendation offers such as those from Amazon and Netflix, machine learning applications for everyday life. Knowing what customers are saying about your product or about you on Twitter, machine learning combined with linguistic rule creation. So fraud detection, one of the most obvious important uses of our world today, it uses classification. So what exactly is machine learning? Let's look at the core definition, core scientific definition of machine learning. A computer program is said to learn from experience E with respect to a set of tasks in some class T and performance measure P if its performance in the tasks T as measured by P improves over experience E. That's the essence of machine learning. We are making the computers think without directly programming or altering them. An important feature of machine learning is that it lies within several boundaries of academic disciplines, principally computer science, statistics, mathematics, and even engineering. Machine learning is usually studied as a part of artificial intelligence, which puts it firmly into computer science, as I said some time back. Understanding why these algorithms require a certain amount of statistical and mathematical sophistication, which in general is rare. Another definition wise machine learning is the training of a model from data that generalizes a decision against a performance measure. So let's look at some of the nomenclature terms which can help us understand. For example, if you want to learn any subject, we need to learn English first, or at least a language first. So if you want to learn machine learning, we need to learn its language, that is its nomenclature first, not the entire nomenclature, but at least some bare minimum to at least get a hang of what is happening. Machine learning algorithms are those that can learn from data and improve from experience without human intervention. Fueled by data, ML models are the mathematical engines of AI, expressions of algorithms that find patterns and make predictions faster than a human can. Prediction refers to the output of an algorithm after it has been trained on a historical dataset and applied to new data when forecasting the likelihood of a particular income, such as whether or not a customer will churn in 30 days. A single row of data is called an instance. It can be stored in database, in cloud, in local storage, anywhere. It's an observation from the domain. An outlier is a data point that is noticeably different from the rest. They represent errors in measurement, bad data collection, or simply show variables not considered when collecting the data. Machine learning model accuracy is the measurement used to determine which model is best in identifying relationships and patterns between variables in a data set based on the input or training data. A dataset in machine learning is quite simply a collection of data pieces that can be treated by a computer as a single unit for analytical and prediction purposes. This means that the data collected should be made uniform and understandable for a machine that doesn't see the way the data as humans do. Precision, as we know, refers to number of true positives divided by total number of positive predictions. In other words, when we remove all the false positives from the total number of positives that are there, what we get is the true positives, and we are looking forward to that all the time. There are largely three methods of data collection. First, if the goal is to share and search new data sets, then data acquisition techniques can be used to discover, augment, or generate data sets. Second, once the data sets are available, various data labeling techniques can be used to label the individual examples. This is the case of supervised learning. We'll come to that. Data preparation, also known by many as data pre-processing, is the process of transforming raw data so that data scientists and other AI professionals can run it through ML algorithms to uncover insights, find patterns, and make predictions. The data preparation process can be complicated by issues such as missing or incomplete records, outliers or anomalies, improperly formatted structured data, inconsistent values, and non-standardized categorical variables. limited or sparse features, attributes. We need to build the model after processing the data. The model can be built using any of the standard machine learning algorithm. It is not expected to create a new algorithm out of the blue for every new model, but if needed, we can tweak the existing algorithms. Then model evaluation is the process through which we can quantify the quality of systems predictions. To do this, we need to measure the newly trained model performance on a new and independent dataset. This model will compare label data with its own predictions, and then predictions are made based on the built model. When predictions are made, one part of the ML machine learning flow is complete, but it's not over yet. Finally, machine learning deployment is the process of deploying a machine learning model in a live environment. The model can be deployed across a range of different environments and will often be integrated through with the help of applications through an API, application programming interface. So I have seen many people what they do is they just get the prediction and they think they are done with machine learning. That is not machine learning, to be honest, at least not the complete part of it. We need to be able to deploy that project. For example, let's say we ended up doing a sentiment analysis. uh, we ended writing a classifier for sentiment analysis based on positive or negative sentiments. That sentiment can be of IMDb tweets of IMDb reviews of a movie, or it can be for the tweets of any event or a person or any program. So what can happen is we need to deploy that. So for example, when we deploy that, we find the real challenges, because the real challenge is deployment. It is not applying the algorithm. So let's say when we try to build a small website and host it, and there when we try to run the algorithm dynamically, we see that this is failing, that is failing. So it is always recommended that we build an end-to-end machine learning flow starting from the data collection to model deployment, and not stop at predictions or not stop at model evaluation. So, at a high level, machine learning is simply the study of teaching a computer program or algorithm how to progressively improve upon a set task that is given on. And on the research side of aspects, machine learning can be viewed through the lens of theoretical and mathematical modeling of how this process works. However, more practically, it is a study of how to build applications that exhibit this iterative improvement. There are many ways to frame this idea, but largely there are three major recognized categories: supervised learning, unsupervised learning, and reinforcement learning. Uh, Supervised learning is the most popular paradigm for machine learning. It is very similar to teaching a child with the use of flashcards. Given the data is in the form of examples with labels, we can feed a learning algorithm these examples label pairs one by one, allowing the algorithm to predict the label for each example and giving it a feedback as to whether it predicted the right answer or not. Over time, the algorithm will learn to approximate the exact nature of the relationship between examples and their labels. When fully trained, the supervised learning algorithm will be able to observe a new, never before seen example and predict a good label for it. Supervised learning is often described as task oriented because of this. It is highly focused on a single task, uh, feeding more and more examples to algorithms until it can accurately perform that task. Classification and regression, as we know, are the common types of supervised learning. If we look at this image, what we see is a model. Is we see a bunch of images of an apple. We are labeling through label box, through label IMG or any other available softwares, labeling softwares, be it Python or any language that you write the code in, and it is fed into the model. And after it is fed into the model, it since there are labels, and when test images are this test image data set is given, it recognizes to some accuracy 70, 80, 90%, depending on how well the model is trained and how well the classifier works, as to it is classified as either an apple or a banana or any other fruit that we label based on the label and classification that we give for each class. This is simple. There are labels and it is completely based on us defining beforehand what to predict and what we need. But things get a bit trickier in unsupervised learning. Unsupervised learning is very much, we can say, the opposite or antonym of supervised learning. It features no labels. Instead, our algorithm would be fed data, lots of data, and given the tools to understand properties of data. From there, it can learn to group, cluster, and or organize the data in a way that a human can come and make sense of the newly organized data. And what makes unsupervised learning such an interesting area is an overwhelming majority of the data, or an almost complete data, is unlabeled. Having intelligent algorithms can take our terabytes and terabytes of data, unlabeled data, and make sense of it. It's a huge source of potential profit for many industries that alone could help boost productivity in a number of fields. When we think of unsupervised learning, we usually think of clustering. That's right, K means clustering. That is the most popular one out of all. And if we look at this image, we are not giving any information to the computer as to whether or not this is an apple or this is a watermelon. We are just feeding it. There are no labels, no annotations, and the model tries to figure out the features, inputs, is subtle attributes of that image or that particular data point, and in a way the complete data set on its own, and then it tries to classify the output. And what we get at the end result is two clusters. If there are two, if we know there are two classes of data, not that the machine knows, and the two clusters form separately with certain accuracy. That this is unsupervised learning. Now, there can be semi-supervised learning as well, as we know, so which is a mixture of supervised and unsupervised learning, and all these are application dependent. All these come at a very specific application. Then reinforcement learning is fairly different when compared to supervised and unsupervised learning. Yes, this is indeed an image of a Pac-Man, AI Pac-Man, in fact, where we can easily see the relationship between supervised and unsupervised. The relationship of reinforcement learning is a bit murkier. Some people try to tie reinforcement learning closer to the two by describing it as a type of learning that relies on a time dependent sequence of labels. For example, this happened. So, series of synchronous events, time dependent events. But that is not the case according to me. I prefer to look at it as learning from mistakes. That is the way humans do, in a way. Place a reinforcement learning algorithm into any environment and it will make tons of mistakes in the beginning, and let it do so. Let's not get worried about it. So as long as we provide some sort of signal in the form of impulse into and the algorithm that associates good behaviors with a positive signal and a bad signal with negative one, a good that associates good behavior with a positive signal, and good signal with a positive behavior and bad signal with a negative behavior. We can enforce algorithms to prefer good behaviors over bad ones. Over time, our learning algorithm learns to make lesser mistakes. That is, it learns through reinforcement. That's what the name. So all these, now if we look at the example of the game, in this case, the action would be, in this case, the environment would be the AI Pac-Man game environment. That is the maze that the Pac-Man is going through. And so the goal of the Pac-Man is to, let's say, get some fruits, cherry, apple, banana, whichever are there in the maze. And also it should be able to avoid the devil or the giant from eating itself, the villain in the game. So when it tries to get closer to the villain, the first time it does by mistake, it realizes that it is getting eaten up. Then the next time it will try to go a bit less close. Then, and while it does so, it will realize that it needs to go towards the fruit to eat or get points and stay away from the villain. And that is how it keeps learning over time. So we do know well that the problems in machine learning can be classified into three types: classification, regression, and clustering. Since we want our training set to be representative of the population, we need to divide it into training and test sets randomly. Also, we want to use our test set only once. We don't want to retrain our model and evaluate it on a random test set over and over again, which will be hugely over optimistic and over resource consuming every single time. We should use k-fold cross validation or nested cross validation instead. There are many reasons why our performance may not be satisfactory. Our data is skewed. There is not there is lots of noise which happens practically. There are many outliers. Our features are not informative enough. Our data is managed, hampered, impaired, or not completely there. We don't have enough training samples as well. And as advancements in machine learning evolve, the range of use cases and applications of machine learning will gradually expand. To effectively navigate the business issues in this new decade, it's worth keeping an eye on how machine learning applications can be deployed across business domains to reduce costs, improve efficiency, and deliver better user experiences. Now let's look at classification. In machine learning, classification refers to a predictive modeling problem where a class label is predicted for a given example of input data. Examples of classification problems include: given an example, classify it if it's a spam or not. Given a handwriting character, classify it as one of its known characters. Given recent user behavior, classify it as a churn or not. From a modeling perspective, classification requires a training data set with many examples of inputs and outputs from which to learn. A model will use the training data set and will calculate how to best map examples of input data to specific class labels. As such, the training data set must be sufficiently representative of the problem and have many examples of each class label. Cla- Class labels are often string values, example spam, not spam, and must be mapped to numeric values before being provided to an algorithm for modeling. This is often referred to as label encoding, where a unique integer is assigned to each class label. Example spam equal to 0 and no spam equal to 1. There are many different types of classification algorithms for modeling classification predictive modeling problems. There is no good theory on how to map algorithms into problem types. Instead, it is generally recommended that a practitioner use controlled experiments and discover which algorithm and algorithmic configurations results in best performance of a given classification task. As we can see in this image, what happens is there are two classes of dots. One is the class of sky blue towards the greenish side, and second is the sky green, and the second one is the fluorescent green. And we are through separation, there are two classes. As we can see, there are some improperly classified data points, and that is fine, it will happen, and we never reach even 95% accuracy, to be honest, with any of the algorithms. If we do, that means either the model has been overfitted or the dataset is not adequate enough. Learning a linear regression model, this is another type of supervised learning, means estimating the values of the coefficients used in the representation with the data that we have available. There are many more techniques because the model is so well studied. Take a note of ordinary least square methods because it is the most common used method in general. You all might be aware of a few. It's good to keep 2 to 3 known linear regression models. From there, we should be able to select based on the use case. Also take note of gradient descent as it is the most common technique caught in machine learning classes. With simple linear regression, when we have a single input, we can use statistics to estimate the coefficients. This requires that you calculate statistical properties from the data, such as means, standard deviations, correlations, and covariance. All of the data must be available to traverse and calculate statistics. As we can see in this image, through the set of first few data points, we are able to generate a pattern and find the coefficients later on. That is, with the increase in x, with the increase of that line of that function, how the value of y changes over time. That is what linear regression is about. There can be logistic regression, multivariate regression, different types of regression. When there are too many input variables, the output can be complex, and that can lead to other types of regression. K-means clustering is a simple and popular unsupervised machine learning algorithm. In fact, I think it is the most popular unsupervised machine learning algorithm. And typically, unsupervised algorithms make inferences from data sets using only input vectors without referring to known or labeled outcomes. A cluster refers to a collection of data points aggregated together because of certain similarities. You'll define a target number k, which refers to number of centroids you need in the data set. A centroid is the imaginary or real location representing the center of the cluster. Every data point is allocated to each of the clusters through reducing in-cluster sum of squares. In other words, k-means algorithm defines k number of centroids and then allocates each data point to the nearest cluster while keeping the centroids as small as possible. The means in the k-means refers to averaging of the data, that is finding the centroid. However, how the k-means algorithm works. To process the learning data, k-means algorithm in data mining starts with the first group of randomly selected centroids. It's selected random first without any algorithm, which are used as beginning points for every cluster, and then forms iterative calculations to optimize the position of the centroids, and then we start getting accuracy. It halts creating and optimizing clusters when either the centroids have stabilized or there is no change in their values because the clustering has been successful. The defined number of iterations have been achieved. As we can see in this image, there are three clusters formed, and I'm guessing in previously the cluster must have been selected randomly, and based on that, it must have been changed over time, and that is how we get three separate clusters after realizing there are three types of data in this. So now let's look at some of the limitations of machine learning. We know machine learning is incredibly powerful for sensors, and it can be used to help calibrate and correct sensors when connected to other sensors measuring environmental variables such as temperature, pressure, and humidity. Why this is important? Because these are quite closely related to the human environment, to things that matter. However, things get a bit more interesting when it comes to computational modeling. Running computer models that stimulate global weather emissions from the planet and transport of these emissions is very computationally expensive. In fact, it is so computationally expensive that a research level simulation can take weeks, even months, all when running on a supercomputer. And a machine learning, a subset of AI which we know well, has revolutionized the world well in the past decade. The information explosion has resulted in the collection of massive amounts of data, resulting in big data in companies such as Facebook and Google. This amount of data, coupled with the rapid development of processor power and computer parallelization, has now made it possible to obtain and study huge amounts of data with relative ease. It is easy to understand why machine learning has had such a profound impact in the world. What is less clear is it what its capabilities are, and most significantly was what its limitations are. Yuval Noah Harari famously called the term dataism, which refers to a putative new stage of civilization we're entering, in which we trust algorithms and data more than our own judgment and logic. It becomes scary at times. I will come to the high dimensionality problem in a bit. So, why deep learning? So first, let's still think of the limitation of machine learning, that is high dimensionality. So high dimensional means the number of dimensions are staggeringly high. They are super high, so that calculations become extremely hard and difficult. With high dimensional data, the number of features can exceed the number of observations. For example, microarrays, which measure gene expression, can contain tens of hundreds of samples, and each sample can contain tens of thousands of genes. Imagine the amounts of data that can be generated from this. A common issue for data scientists when creating algorithms, and not just machine learning but even outside of it in any mathematical modeling, is having too many variables. Naturally, you would think that adding more information would only make your model better, which is not true. But with every feature you add, there comes another dimension, and As humans, we can only visualize 2 dimensions or 3 dimensions at max. For data, this rule does not apply. Data can have infinite number of dimensions. But this is where the curse of dimensionality comes into picture. The curse of dimensionality is a paradox that data scientists face quite frequently. You would want to use more information in order to improve the accuracy of your machine learning model. But the more features you add, the number of dimensions increases. As the dimensionality of the feature space increases, the number of configurations increase exponentially, and in turn, the number of configurations covered by the observation decreases. High dimensionality might mean hundreds, thousands, or even millions of input variables. Fewer input dimensions often mean correspondingly fewer parameters or a simpler structure in the machine learning model, referred to as degrees of freedom. Model with too many degrees of freedom is likely to overfit or sometimes underfit the training data set and therefore may not perform well on new data. It is desirable to have simple models that generalize well and in turn input data with few input variables. This is particularly true for linear models where the number of inputs and degrees of freedom of the model are often closely related. As can be seen through the picture, multiple layers can help handle high dimensionality quite easily. This is the very reason why deep learning came into existence. That is why we get deep learning. As you all can see in this image, there are multiple layers, and it's quite intuitive to guess that several that dimensionality should be handled quite simply by these multiple layers. And there are multiple layers stacked to one another. Sometimes these layers can go in thousands. So now let's look at some of the learning frameworks and tools. We won't be going through the practical working of any model, but at least let's look at some of the frameworks that can be used. See, we might be aware of most of these. Python 2 and 3 is the most widely used, along with R for statistics and machine learning. Python is highly recommended from a programming perspective, and Python is also the most popular programming language, which you all might be aware of. Then TensorFlow, Cafe, Keras. There are more such as Neon, MXNet, etc., which are highly popular machine learning and AI libraries. And when it comes to platform, Jupyter Notebook is the one most recommended to run on a local machine. Rest, if you all want to test it on cloud, you all can run Jupyter's Notebook on AWS, that is AWS SageMaker, or on Google Colab, Google's dedicated cloud environment, or on Intel Dev Cloud, that is Intel's dedicated cloud environment. REST Intel Deep Learning SDK is highly useful if we want to use it. Intel provides a comprehensive portfolio of tools for all our AI needs, including data preparation, training, inferencing, deployment, and scaling. All tools are built on the foundation of a standard-based, unified, one API programming model with interoperability, openness, and extensibility as core tenets. There are lots of other tools and other Python libraries as well, such as scikit-learn, NumPy, SciPy, Matplotlib, and a bunch of others which can be tested and used upon. But I believe the goal should not be to use many Python libraries. The goal should be to work towards a particular use case, and we'll naturally come in touch with a Python library if there is a need for it. We don't need to run for it every single time. We need to know who they are, and some of the pioneers we might have heard many of them. Andrew Ng, many of us might have pursued his course in Coursera, who made gigantic contribution to the field of AI. Let's remember them. We must have come across their work, maybe a research paper or two, sometime or the other during some other literature survey. If we write a research paper, an AI paper, there is an extremely high possibility that we might be citing at least one paper from one of these giants, from one of these technology behemoths, may call. There are lots of others as well, such as Sebastian Thrun and others, but these five are the main, with most contribution, arguably. So let's trace back our journey and what exactly has changed over the years. There has been a gradual accumulation of data, we know that. In fact, lots of data over the years, big data if we call it. Thanks to Moore's law, among others, along with GPU and TPU, Cloud TPU, Tensor Processing Unit, released by Google just recently, the computation power has exponentially increased since inception. The end result, as seen, is massive growth in the AI chain, in the entire AI chain, in fact, leading to algorithmic development. We work with algorithms today that are almost half a hundred times faster, accurate, and far more reliable than the ones that existed in 1900s. Further, the motivation for all this is humans cannot think; they got a brain. Machines cannot think. Humans can think; they got a brain. Machines cannot think; they don't have a brain. While at the same time, humans cannot be reliable over computationally extensive operations, except few superhumans, but that is rare. And even then, accuracy can be really questionable. When you combine humans' intellectual ability with machines' computationally efficient ability, the end result we get is AI, specifically deep learning. And that's what the world is behind, and taking the best of two sides. And lastly, I would like to conclude by saying that one brilliant idea, one revolutionary invention, one brilliant technological change can unleash the other industry people to create a positive impact in the market today. Thank you. And I am open for question and answers, if any.
अरे वो अपने क्या है वो सेकेंड ईयर के सीआर का मैसेज आया था।
Okay. Thank you so much, Mr. Shobi, for your valuable thoughts. Does anybody have any question you can ask Mr. Shobi?
And if any questions they need to be mailed or anything, they can also be done later.
Okay.
Anything is fine.
Okay. Okay. All right. Thank you so much, Mr. Shobik Das, for your valuable thoughts.
Thank you.
Yeah. Now I invite our CoDE AIDS President, Sarthak Nagoshe, to express about CoDE AIDS.
Hello, good afternoon, everyone. I'm Sarthak Nagoshe. First of all, I would like to thank the club and our respected HOD ma'am, Dr. Shraddha Pandit, for giving me the honor of being the president of our club. A department without a club is like an artist without a brush. So our department of AIDS and AIML have come together and started the idea of the club code. In short time on campus, I have already seen the energy you bring in, and I would love to connect with you all and build a strong relationship. My motto will be to create, build, innovate, and for achieving it, I, as a president of the club, stand ready to work with you, flourish that special relationship, strengthen it, and continue to advance our club's activity under my leadership. Our club consists of 4 cells for your all around development. They will be led by the best sapient students of our department who are eager to motivate others to do their best and are able to guide their fellows whenever needed. These cells will be led by a few of the most experienced students of our branch, but regardless of any hierarchy. We as a team with you all will be leading this club to the highest level of efficiency. Thank you.
Thank you, Sarthak. Now I invite CoDE AIML President, Nachiket Gorwadkar, to express about CoDE AIML.
Good afternoon, one and all. My name is Nachiket Gorwadkar. I am president of CoDE Club from AIML department. We are introducing you all to a new club, which is CoDE. Now you will wonder what is CoDE. It's actively demonstrate that the club of data engineers, that's CoDE. The particular reason for establishing this club is to explore new challenges, new ideas, new opportunities, and so on. The particular reason for establishing club is to explore new challenges, new ideas, new opportunities, and so on, which will make you more innovative, more skillful, and of course, you will enjoy the process. To sum up everything that has been stated so far, the CoDE Club is of the data engineers, by the data engineers, and for the data engineers. Thank you everyone and have a nice day.
Thank you, Nachiket. Now I invite Mayuri Thorat to talk about CoDE Geek Cell.
Hello everyone, a very warm welcome. My name is Mayuri Thorat and I'm going to address you on behalf of the entire Geek Cell. Yash and I are the web dev lead. Shreya and Ojaswin are a tech lead. Being a part of Geek Cell, it's a responsibility to conduct competitive programming rounds, workshops, training sessions, and organizing quiz competitions. More specifically, it is a prime goal to provide practical programming knowledge. We will convey both theoretical and practical content to ensure that you fully comprehend any given topic. If you're providing resources on Python programming, we'll make sure that every level of content is provided, from beginner to advanced. For example, basic Python concepts, Python libraries, basic maths required for Python programming, its applications, and Python-based projects. We'll ensure that by the end of each programming language, whether Python, Java, or CPP, you will be able to construct your own projects using that particular language. Seminars will be conducted on most demanding topics such as web dev, where you will get information from basic HTML to advanced React. Topics such as React, also programming languages, cloud computing, cybersecurity, ethical hacking, etc. Coding competitions will be held using different coding platforms such as HackerRank or CodeChef, which will be suitable for the majority, which will prepare you for the future contests. Certainly, you will receive exciting gifts and certificates. Interview and coding from top firms such as Google, Microsoft, and Tesla will be posted on groups, along with the simplest solutions. Along with that, we will be conducting annual coding competition, and winners will be given amazing prizes. Most importantly, we'll need your help and active engagement to make this a great success. If you face any issues regarding technical things, feel free to reach out to us. We will be happy to assist you. Knowledge is of no use unless you put it into practice. Hoping to see you for future events. With that, I wish you a wonderful day. Thank you so much.
Thank you, Mayuri. Now I invite Juhi Gurram to talk about Code Art Cell.
Thank you, ma'am. A very good afternoon to one and all present. I, Juhi Gurram, am here representing the art cell of our club. Our team comprises a total of 8 members, mainly Madhura Miratskar, Rushikesh Panchal, Janvi Dhaigude, and Sai Ahir, who look after the graphic designing. Shreya Songusre, Gurvansh Kaur, Riya Jagtap, and myself are the content writers. The art cell is a place where the students can innovate, create, and express through the medium of art. They're open to experimenting and creating from their power of imagination. As a part of the cell, it's our responsibility to manage and conduct healthy competitions on various extracurricular activities like art, craft, dancing, singing, literature, and all the creative work. This will not only help the students to stimulate their creative ideas, but also enhance their visionary mindset. Shortly, we are planning to come up with events like digital and handmade poster making and a slogan making competition where you can pour out your creativity and showcase your ingenious work of art. As a part of appreciation, the winners will be rewarded with a certificate of achievement and exciting prizes. The best poster among all will be pinned on the bulletin board of our department. I'm excited to see you all with active participation in the upcoming events. Let's innovate, learn, and inspire because it's all about creativity. Thank you.
Thank you, Juhi. Now I invite Sakshi Sonawane to talk about Code Literary Cell.
Yes. A pleasant, warm, and heartiest welcome to everyone here. Myself, Sakshi Sonone, with Krishna, Ayush, and Mayura will be working under the literary cell of Code to give a platform to the students to express their hidden talent and to help them envision themselves and others in a better way. Our cell works to discover and nourish the literary talent, mold the personality of students, exposing them to a wide range of events throughout the year, and to help students overcome their shyness and constraints in constraints in communication skills. Various competitions such as debate, public speaking, entrepreneurship events, and many such activities will be conducted. The literary cell is working to meet its aim and also serve the society as it has full faith in the power of the pen. Keeping this in mind, our cell helps students to improve their communication skills, expressivity, and critical thinking power, and thus equip them to face professional life with confidence. The main aim of any kind of education is progressive and holistic development. So, we will also be focusing on the personality development of students. Furthermore, to keep students active and competitive, we will be conducting interview sessions, guest lectures, and various events. So, at last, our objective is to develop students by making them participate in various literary activities, resulting in enhancement of their personal skills and experiences like confidence, self-discipline, teamwork, time management, and organizational skills to move beyond boundaries and experiment with different ideas. So it's our pleasure to work with this committee, and we hope to see you all in our upcoming events. Thank you.
Thank you, Sakshi. Now I invite Kiran Shetty to talk about CoDE eSports Cell.
Good afternoon, everyone. Myself Kiran Jete. I'm going to address you on the behalf of the entire esports cell. So Arya and I will be the admin lead, and Aditya and Kaivalya are the secretary. Uh, Being a part of the esports cell, it's our responsibility that we will record the outcome of the matches, make sure that the players are sticking to the rules, and hand out the penalties if any broken. We often need to communicate with the teams to settle any dispute, keep tracks to the tournament brackets, and offer support to the wherever it's needed. While admins also required to set up, chase signups, sort seats, and make sure everything else according to the schedule. This means you might have to work in the teams and make sure that they are all under time. Because of this, we need to know the game and the tournament rule book inside as well as outside to enforce that the rules and are avoided and any controversies and or unfair decisions. We also need to keep pauses, delays, and downtime to a minimum. As a player's relaxation is also important. What skills are required for the esports cells? Admin so communication skills is very important skill. For example, telling a team that they have been disqualified, it's not easy, and you are also needed to do this with a calm manner to prevent a situation from being escalating. Aside from good interpersonal skills, you also need to remain vigilant and resolve any issues quickly, efficiently, and professionally. So, lastly, I would like to tell you about some upcoming events. So, as due to the pandemics, we can't take any offline activities, but we can take some activities such as BGMI, CODM, etc. So, we will conduct a BGMI tournament in upcoming week. Stay tuned. So, at last, I would like to say that we are the gamers, we never try, but uncountable response, the stats never gonna lie. So, thank you.
Okay, thank you, Kiran. Now we will have one small activity, and I am posting that activity in a WhatsApp group. And about that activity, Yashodan Deshmukh will tell us about that. Yashodan?
Everyone. So now finally to the activity. So we are conducting here quiz on and thank you for attending first the session. So how attentive you were in today's inauguration session. So there will be a short quiz. There will be 10 questions for that quiz, and for each question you will get 20 seconds to give the answer. The faster you give the correct answers, the more score you will get. So how to join? So click on the link, like go to the link quizzes.com on your web browsers and enter the game code, the 312136626, and please join in the format first name dot last name and branch. Then and then only your name, your entry will be valid, and we will be starting the quiz shortly till all the members are joining.
The link to join is in official WhatsApp group.
Join with the following format only. We are giving 2 minutes for all the participants who are interested to join the quiz. I once again repeat the rules. There will be 10 questions which are based on all the details that are given in today's inauguration. There will be 20 seconds to answer each question. You have to go to quizzes.com, and there you have to enter the game code 3121326 and enter your name in the format given in the slide. Then and then only your entry will be considered.
Okay, we'll start the time now. Yashoda?
Yes, ma'am. Okay, we have started the quiz. I'll be sharing the leaderboard shortly. Okay, so here are the students playing. So first we have Anish M from AIDS department, was currently 7040 points. Was still now the first, and the quiz is still going. We have second as Areen AIDS, then even Siddheya Lohar AIDS. The participation of the players is quite good. So there is a reward for the person who will be the first in this quiz.
Can you show the link?
The link, okay. Link, okay. Now the game has started. After starting, I guess I can't show the link. The link has been sent to your official groups too. Second, we have Shubham. Kalpesh. Three of 9 players have completed till now the quiz. Still players are joining. So still Anish is first. When total 90 players will complete, we will end the game because 90 had joined. The others have joined right now, and some are even joining. Okay, we are closing the link at 4:06 p.m. Yeah, okay. So we have the first winner. We have Sharvari Jape of AIML, who have got the first prize. So, Sharvari, you will be given one free entry to our event, to the event which will be conducting next, and we will get to you about the free entry later. So congratulations to all the winners, and thank you for all the participants who actively participated in this event.
Okay, thank you, Ashadhan. Now, on behalf of our Department of AIDS and Department of AIML, I extend a really heartily vote of thanks to our guest speaker, Mr. Soubhik Das, who spared time from his busiest schedule. I am very much thankful to our respected management, respected principal ma'am, respected HOD ma'am, for valuable guidance and support. I am thankful to CoDE committee members for their active participation and wish them all the best for upcoming events. Last but not the least, I am thankful to our students for their cooperation and support, and I hope you will participate actively in upcoming activities of CoDE. Thank you. Thank you all. So, our guest will leave the meet first, and then others will leave the meeting.
Students, please wait. We'll take a screenshot of our activity.
Hello, excuse me.
Yes.
Has participate twice, so we had a double entry.
Okay, who is talking? Please talk loud.
Okay, this is the year of AIDS first year. But we
Okay.
had a duplicate.
Sarthak, he is a CR from first year, so he is talking something.
Yes.
Sarthak, I am home.
Yes, yes.
Winner has a duplicate entry. Can you please check?
Okay, we'll check and let you know.
Yeah. If found something like fishy, the one who has given proper responses will be given the pass. Don't worry. If some issues, we will check it out. And if possible, can participants please on their cameras? We have to take a photo. This will go on our handles. for the first inauguration conducted. So please I request all the participants to on their cameras just to take a snapshot.
Students, please turn on your cameras. We'll take a quick photo.